multiple URLs and replace them all with one go. It'll automatically generate HTTP headers as needed, or you can create your own HTTP headers, and it will figure that out. So what does that get us? That gets us HTTP content replacement. It means control over the page DOM, control over forms, control over the browser in general, and access to anything in the security context of the page you injected into, like cookies. So we can replace content. What do we do now? Well, pretty much everyone has a crap ton of silly little JavaScript files. For example, CNN. So these are really cool to go after because the user doesn't see them. They don't really notice. And it's going to request 50 of these things. You don't land attack 1, you'll land attack 10. And they run in the same privilege as the web page. So I'm in your browser rewriting your DOM. What did we get? Document object model, programmatic manipulation of the page content. We can do anything we want once we get a little piece of JavaScript hooked in. So look for everything named div, look for everything with the CNN T1 image class, replace that. Look for the CNN T1 text, replace that. Programmatically rewrite CNN or whatever. So what else can we do? I don't know. How about change every form on every page to proxy through my server or somewhere else that logs all your data? Yeah, sure, that works. How about rewrite all the SSL links to unencrypted? Yeah, sure, that's good. How about poison content topical conference? What if you're at a conference with a bunch of bankers and you poison every news site with something? Kind of tinfoil hatty territory, but still be fun. Find every tag that begins with A, find everything that has an href reference in it, and regex replace HTTPS to HTTP. And oh, look, now I'm sniffing your layer 2 network right next to you, and none of your data is encrypted anymore. So this matters way more than it sounds. So who's read RSnake's VPN paper? One? Hands? OK, like maybe 20 people. All right, you should have read this. Go find it, read it. What it means is we can attack HTTP client cache. We can make layer 2 attacks against web content persistent. It means once you leave the Starbucks, you're still owned. Browsers have cache. Cache hangs around. Users don't notice cache. If I own your TCP session, I own your HTTP headers. If I own your HTTP headers, I own your cache control. So I feed you a spiked JavaScript file with the cache set for 10 years. It remains in your browser. You don't notice. And whenever you revisit that site, it loads from cache instead of from the internet. So for example, inside your office network, which was all nice and encrypted. So look at that. 500K of cached JavaScript. That would be a good target. So you just set cache control, max age, whole bunch of 9s, public, or just set it to expire sometime in the future. So we hijack a common file, spike it with malicious code, set it to cache. Now when you go back to work and go back to Twitter again, you're actually loading my code. So what does this mean? It means we keep using it every time until it expires. What do we get to do with that? Iframes, Kaminsky's socket suck-it stuff from a couple years ago. But I mean, you'd never go to Twitter at work, right? Or none of your users would ever go to Starbucks and then come back and goof off. And I mean, how many sites use urchin.js off the same Google URL? And what happens when we poison that and they load our cached copy for every website that uses it? How about just modifying JavaScript that calls home? So it pulls a file off a remote server every time it gets loaded. Maybe there's no good attacks out this week for browsers, but I mean, there haven't been any browser O-days out recently making the news or anything. I mean, no one would ever poison a whole bunch of people at an airport and wait for a major O-day to release that nobody knows how to patch yet and then spring it. It means no website is innocent. You might be, you might know not to log into your bank from Starbucks, but now it means CNN is just as likely to compromise your browser or put in hooks that would let people steal your credentials. So any website can be poisoned. Won't SSL solve it? Well, no, because your users really don't make good decisions presented with a decision. Obviously, that pop star wants me to see her naked. Why would she send me an email otherwise? I'll click that. And I mean, users would never make bad decisions about things, right? I mean, that wouldn't be a nice historical pattern of behavior. So self-signed certs are pretty obvious, but we're technical. Signed by VeriSign with capital S versus lowercase s, or just identical. I can name something VeriSign and sign it. I think I'm being optimistic. I don't think many users would even know to look to see who signed it and say, I recognize that company name. They just click OK until I get porn. Do I have porn yet? No. Oh, there's an alert. OK, OK, OK. Do I have porn yet? Oh, there we go. So, we're all clever. We use VPNs or SSH tunneling or whatever. Or, we're evil bastards. We force the users and companies we have to deal with to not be able to go online without a VPN when they leave the company. So obviously this won't work, right? Well, it wouldn't, except your browser has really no clue whatsoever about being in a security domain or not. So what's cached insecurely will be available when you're running your VPN later. So how many hotspots have a landing page where you have to agree the EULA or sign in? Most of them. They're not usually on HTTPS until you go to sign in. So that's a good target. So if I control your pre-landing page, then I can control your browser. So I can control iframes, pop under windows, or just AJAX queries that go nowhere or go to a div that's set invisible or something. So I just have to guess, the top 50 sites you're likely to go to, and while you're signing in, your browser's in the background running JavaScript loading the top 50 pages I think you're going to go to, in which case I'll keep spiking them with cached attacks against you. So I can request content multiple times. So the landing page JavaScript just has to search the data it got back for its query and go, well, that didn't work, I'll request it again. So now if you can guess a site, you can own arbitrary content before they run their VPN. Well, let's take it one step further. So VPN allows you to get to what? Internal sites? Yeah, so if we control layer 2, do we control our protocols? Yeah, we sure do. DNS, wait for a DNS query, set the QR bit, tag an IP onto the back of it, send it right back over Wi-Fi. DNS pwn is also in Metasploit now. So, yep, yeah, the YAML config files, set it up to match domain names you want. So we control the browser, we control DNS resolution, we can retry as much as we want if the DNS attack doesn't land. What stops us from caching intranet? Here's a hint, nothing. So a little JavaScript shim that we feed you an IP for intranet, cache a little bit of JavaScript that then scrapes all the DOMs on the intranet page when you log in over VPN, ships them off to a remote server. Or just rewrites all your login forms to, send the internal company credentials out. So browsers are great. What else do they do? Well, they cache DNS. So that means pre-VPN, we can start caching internal domain names as external IPs in your browser. That's fun. I'm sure you can think of a couple things to do with that. What else can we target? Well, smartphones are really just computers now. They've got complex browsers. They're on little low bandwidth 3G networks. Yeah, they cache data. But all the smartphones are on cell networks, right? I'll just use 3G. There's never been any consistent problems with 3G or anything. Besides, smartphone users are used to going to Wi-Fi. Some people prefer it. They might have limited data plans or whatever. Besides, you could always help them not have 3G. But of course, that would be illegal. You should never go to an import site and buy a $25 jammer. Obviously, someone trying to own your company would never do something illegal, so don't worry about that. So where are we going to go from here? Better Metasploit integration with our layer 2 attacks, better dynamic content generation based on the target. We're running it all in Ruby. Why don't we have something that's a little bit smarter? Integration with Egypt's browser autopwn stuff. So we've more or less figured out how to defend access points. It's much harder to defend clients, especially when they go off and wandering around in the world on insecure APs. If you're using an open network, sites you think you can trust, you can't. Sites you think have no trust model, you're suddenly trusting not to own you. Attacks will stay around until you clear the browser, and your users might be coming home with something really unpleasant. This is bad even for us. I feel kind of bad. I've ruined Wi-Fi for myself at this point. I think people that aren't security hackers, professionals, aren't going to even stand a chance at noticing this happening to them. You may already be screwed. I told you this would be depressing. What do we do to fix it? Well, we can try to use a VPN. It's a start. There's still the attack vectors for it. That's easy for us. It sucks for most users. It's really hard to enforce. Users don't like having to run another program before they get their porn. You can do SOX tunneling over SSH. It's the same thing. You can mandate updates on your users. That's easier said than done. You can prevent users from taking laptops onto open networks. Good luck. If you can make it happen, then by all means. It would be nice to say to move to WPA networks. PSK is better. It's still not really a solution. When the PSK is known, like at a con, then the only thing really preventing people from attacking that the same way is a lack of tools. If you know the PSK and you can watch the users connect, you can watch them do the handshake and extract it. EAP, it's better. You get per user passwords. You get per user keying. You get per session keying. We were using WPA2 Enterprise here. But it still requires SSL. If the cert's signed by a common CA, then your supplicant's going to accept any cert I give. Like, oh, you were signed by VeriSign? Well, funny. I can go get VeriSign to sign a cert for my perfectly legitimate site that happens to have the same SSID. If it's signed by a self-sign, the user has to accept certificates. Users are really good at determining validity, aren't they? No, they're not. It's hard to deploy secure